Let's see next topic, IO hardware. The controlling IO device is also responsibility of operating system. Okay, so here each device that is connected to your computer, the operating system provides an interface. Okay, in order to use that particular device, the operating system provides an interface. This particular interface should be easy to use and it should be simple, easy to use and simple. Okay, and this particular operating system that the device that are connected to computer, the operating system issue some commands. Okay, and it is also responsible for catching the hardware interrupts and handling some of what are the errors that are occurred with this particular device. Okay, so handling errors in, we will call it as hardware debugging. Okay, and if there is any interrupts that is caused from a device, hardware device, the operating system is responsible for handling that particular interrupts, and it needs to take measures what happens, what actions will be taken after an interrupt occurs or interrupts that comes from a hardware. Okay, so there are two types of IO device. First one block device, second one character device. First one block device and second one character device. Your magnetic disks are belongs to your block devices where the data transfer will be happen block by block. In terms of blocks, the data will be transferred. Here, the data will be transferred in byte by byte mode. Okay, byte by byte. The printers, network interfaces, mouse, keyboards, or etc. They are called character device. They are character device. Okay, so the block device, it stores the information in a pixel size blocks. Okay, in a character device, it delivers and accept the stream of characters, and each character will be a byte. Each character is size of a byte. Okay, so in the disk, in the magnetic disk, as we already discussed, each block has its own address. Okay, so here we cannot address it, we cannot character device, we can, the addressing is not possible, it is not addressable. Okay, so it is possible to read or write each block independently of all other device. Okay, so it does not have any seek operation because character devices, they don't use disks such as magnetic disk. Okay, so these are network printers, mouse, they are not, doesn't have any disk, so that the seek operations are rotational latencies will not be available. So see, this particular seek operation is not present in character device. But in order to fetch the data, the block devices should have the seek operation. That means it has to go to that particular block and fetch the data. Okay, the data rates of different IO devices, the keyboard will have 10 bytes per second, maximum it can take 10 bytes. Then mouse 100 bytes per second, scanner 400 KB per second, and CD-ROMs, you can see usually ROMs, CD-ROMs or DVDs, that will be 8 MB or 4 MB, 8 MB per second or 4 MB. That is, if you buy a CD or DVD, you can see that how much data rate will be there. Okay, how much speed that particular CD will be rotated inside, how much data is transferred in the from CD to your disk or disk to your CD, that will be actually printed on that particular disk. Okay, CD or DVD, mostly it is 4 MB or 8 MB. DVD 4 MB or 8 MB, and USB 2.0, it is 50 MB, maximum data rate is 50 MB per second. And any SATA 80A disk, okay, serial disk, okay, SATA disk, that is 200 MB per second is maximum. Then PCI buses 528 MB in your per second. Okay, so now see a device controllers. Okay, now look at here. Every device that are connected to your computer, okay, your computer, they have two particular parts. Okay, see, let's see. IO units typically consisting of two parts. First one a device, second one a device controller. Okay, so your device is a mechanical component and device controller is an electronic component. So monitor, keyboard, USB RAM, hard drive, all these are devices. All these are devices, and these devices are controlled by device controller, controlled by device controller. Okay, so this device controller will have two parts. First one, a buffer of memory, that is a temporal, some storage will be there. followed by this device controller will have its own register set. Some set of registers will be there in the device controller. So inside in the device controller there are two parts. First one buffer, second one register. Okay, so buffer is a storage area. Buffer is a storage area. Usually the buffer storage will be of few MBs of data. It contains few MBs of data. Okay, so operating system deals with this particular device controller because the operating sends some commands to the devices. So those commands will be understood by device controller. So operating system deals with device controller rather than the device. Okay, so each device controller can handle multiple similar device. Okay, similar device. And okay, so the companies makes disk drives that match with your IDE, integrated development environment. So IDE means integrated development environments. Okay, and SCSA, small computer. Okay, and okay, so SCSI interfaces. Next, the interface between the controller and device is often at low level. What is mean by that? Okay, so a disk might be formatted with some sectors like 1024 sectors. Okay, 1024 sectors of for each sector. Okay, 10 sectors of 512 bytes per track. Okay, so we have seen what is sector and what is track, how many sectors within the track and etc. We have seen in mass storage structure, that is the disk structure. Okay, so the controller job is to convert the serial bit stream. The controller job is to convert the serial bit stream into block of bytes. Okay, block of bytes. So after converting this particular bits to bytes, we need to make sure that there will be no errors occur. There will be no errors occur. If there are any errors, we need to correct those errors by using error correcting methods. Okay, so the block of bytes first assembled bit by bit. So these particular bytes assembled bit by bit in a buffer inside the controller. So once we convert this particular serial bits into bytes, okay, so we need to store these bytes of data inside the buffer. Okay, so what we said, the buffer is a few, the buffer size will be few MBs, few megabytes. Okay, so once this particular so suppose that we are copying data from your hard disk to memory, your hard disk to memory. What we do, a disk has its own disk controller, a disk has its own disk controller, your hard disk to memory. Okay, the disk controller takes the data and put it onto the disk controller buffer, put it onto the disk controller buffer and checks whether there are no errors. Once it finds that there are no errors, then this data will be stored into main memory. Data will be stored into main memory. Okay, so all the modern disk controllers will have few megabytes of buffer, megabytes of buffer. Okay, so next, direct memory access, DMA, direct memory access, DMA. Okay, so the operating system can only use DMA only if the hardware has DMA controller. Hardware has DMA controller. Okay, so then I already told you every disk or every device will have its own device controller. So here we are taken the hard disk drive or magnetic disk drive. The magnetic disk drive consisting of its disk controller. Okay, disk controller. So this particular DMA controller is integrated into your disk controllers and as well as other controllers also. So this is a part of your disk controller. DMA controller is part of your disk controller. Okay, so this particular DMA controller can similar to your CPU and disk controller. DMA control can also access your system bus where the data will be transferred from one device to other device. Okay, so this particular and this particular. So next, the DMA control the DMA controller has several registers that can be written and read by CPU. So what are those registers? First one, memory address register, byte count register, and control register. Memory address register, MAR, byte count register, and control register. These control registers specifies how much amount of data to be transferred and how much rate the data to be transferred and in which direction the data to be should be transferred, which will be decided by this particular control register. Okay, and what are the different IO ports that can be used, that is also defined by control registers. Okay, so how to transfer the data, the working of data. See, if you see this particular diagram, we can divide it into four steps. We can divide the data transfer into four steps. First one, when DMA is used, dynamic memory allocation is dynamic memory access is used. First, the CPU programs this. Sorry. First, the CPU programs the DMA controller. Okay. So by setting its registers, by setting its registers that are inside this particular controller. So this particular programs, okay, this particular program says where to transfer the data. It will say that where to transfer the data. Okay, and once it issues a command to the disk controller telling that to read the and also this particular DMA controller also issues, that is CPU also issues a command, so take the data from the disk, okay, and store it on the buffer. Take the data from the disk and store it on the disk controller buffer. Okay, and I already told you disk controller buffer. Okay, and make sure that this particular data is valid. Data is valid. Okay, so next step 2, the DMA controller initiates the transfer by issuing a read request over the bus to disk controller. Read request over the bus to disk controller. Okay, so once this request is done, then the disk controller knows where the data to be written, because in the system bus it knows the address. See, it knows the address of the destination. Okay, so where the data to be written, that is known by disk controller by examining the system bus. So when the write operation is complete, okay, once a block of data is written, then the DS disk controller will send an acknowledgement to DMA controller. That is, controller will send an acknowledgement to DMA controller. So first block of data is transferred. Okay, next it will transfer one more byte or one more block of data by repeating the same steps. Then again, and this process will be repeated. That means the transfer of DMA controller to disk controller and disk to main memory and main memory to disk controller. This after transferring all the bytes. How to find after transferring? How to find the end of the bytes? That is, there we will find a counter. We will use a counter value, byte counter value. We will reduce the byte counter value to n minus 1, n minus 2, so on, so that when the byte counter will be reaches to 0, that we can say that the entire data bytes has been transferred. So once the entire data has been transferred, then we will stop the transfer process. How will we stop the transfer process? The DMA controller, once all the bytes has been transferred, the DMA controller raises an interrupts, issues an interrupts. The operating system uh, receives this particular interrupts and stops the data. Okay, data